Welcome on this lesson on the fertilization of the greenhouse crops. We'll talk today about several topics, starting with definition of the soil fertility. Then we'll explain the factors which affect the plant nutrient uptake. We'll talk about the symptoms of nutritional elements deficiency or the excess. We'll talk about the basic fertilization and top dressing. Then we'll follow the fertigation methods for the vegetable crops in protected cultivation. We'll explain some principles of sourcing relationships in plant and the respective nutritional strategies. And finally, we'll talk about some physiological disorders related to the non-appropriate plant nutrition. Most of greenhouses are using soil as a substrate for growing plants, and obviously the success of crop production in a greenhouse is strongly related with the fertility of the soil. Indeed, soil fertility is the ability of soil to provide nutrients for crop production, drawing both from own soil reserves and the external applications, the fertilization. The soil fertility can be explained in both, or can be defined both in short-term productivity and the long-term productivity. And the definition of soil fertility on the short term is based on the capacity of soil to immediately provide plant nutrients. In the meantime, a definition of soil fertility inclusive of long-term sustainability must in addition consider the complex interactions between the biological, chemical and physical properties which directly or indirectly affect the nutrient dynamics and their availability to the plant. So, as a result, the management of soil fertility should be related to the greenhouse climate and with the complex interactions which involve many factors contribute to the biological, chemical and physical properties of the soil. Talking about them specifically, I should say that among the biological factors should be included both the beneficial microorganisms such as mycorrhizal fungi and some nitrogen fixing bacteria or plant growth promoting bacteria in general, and the harmful microorganisms, mostly soil-borne pathogens, which can negatively affect the plant performance. Regarding the physical properties of the soil fertility, with great importance for the greenhouse production are the soil texture and structure, which both define the water permeability and water holding capacity of the soil. Then the soil volume that can be explored by the root system of the plant, and final, as I said, the overall water holding capacity of the soil. These physical properties are of great importance and should be counted carefully, especially regarding to the irrigation management and the proper fertilization management, as we will talk later on this lesson. And finally, the soil fertility is dependent on many chemical factors which of course contribute to soil fertility, including the nutrient status and the soil organic matter, the pH of the soil, and very important, its cation exchange capacity. The fertility of soil is estimated by chemical soil analysis and expressed in terms of exchangeable cations or plant available nutrients. There are, of course, many sources of information regarding that, but you can also consider the table in the screen when the exchangeable cations or plant available phosphorus are expressed in milligrams per kilogram of dry soil. And there is, of course, an obvious difference between the so-called macronutrients, calcium, magnesium, potassium, phosphorus, and so on, with the so-called micronutrients, starting with iron, manganese, zinc, copper, boron, and else. And you can see that how big is the difference on the desired range of these elements. Of course, a fertile soil is soil which have all the required elements by the plants and have them in the proper concentration, in the optimum concentration. Whether specific nutrient element is rather lacking or in excess, it will affect the plant performance, and we'll talk about specific physiological disorders in plant related to the non-optimal range of nutrients into the soil later on in this lesson. We should be aware for the fact that the optimum level of a certain nutrient elements is also depending on the physical properties of the soil. Let's take the example of the exchangeable potassium, and you can see from this table how big are the differences regarding the levels of the exchangeable potassium in between different types of soil. And this is really important, and then we should keep this in mind when we are preparing or conducting specific fertilization program for each specific crop. The modern greenhouse vegetable production is intended to operate in an environmentally friendly way, which means that the possible negative impacts of the greenhouse production to the environment to be minimal. To do that, several basic questions have to be counted, like what is soil fertility and what role do plant nutrients play in a vegetable production, what are the typical amounts and forms of plant nutrients in soils, what nutrients forms do crop take up, what are the input and output of the plant nutrients to and from the soil, what factors affect the conversion between different forms of the nutrients, and finally what variations in plant nutrient availability occur between different soils. So having an optimized plant nutrition, we need, in addition to answer several questions, such as which are plant processes particularly sensitive to plant nutrients, how do nutrients move within the plant, how do plant nutrients affect growth, yield, and quality of the produce, else what will be the crop's nutrient requirement throughout the growing season, and what will be the total requirement of the crop for nutrients, and finally what is the expected trend of nutrient concentration in the different organs during the growing season. So there are so many complicated issues we should address all together in order to have the right nutrition regime or nutrition program to the plant with minimal negative effects on the environment. You should keep in mind that fertilization is one of the most delicate processes of the growing plant management, crop management in a greenhouse, and one of the most risky agriculture practices, which in case of non-proper management could have serious negative impacts on the groundwater, soil, and the whole environment in general. Like all soils, the greenhouse soils contain natural reserves of almost every plant nutrients, but only a small proportion of them are readily available for crops. I mean nutrients in the soil solutions or absorbed onto the exchange complex. Less available forms are either organic matter or insoluble minerals, must be solubilized or mineralized before being taken up by the plants. These processes are usually slow, but due to the high temperatures found in the greenhouse, they are, however, faster than in the open field production, in open field conditions. However, the uptake rate of the mineral nutrients from the greenhouse crops is strongly affected by several factors, which are split into environmental factors and also biological factors, or the stage of development. I mean, especially in long cycle crops like some fruit vegetables and ornamental plants, there are different rates of nutrient uptake in different stages of plant development, and we'll bring later on this lesson the example of tomato. The environment factors have a strong effect on the uptake rate of the minerals, and we are going to list some of them. It is for sure the light intensity, one of the most important factors which affect the uptake rate of plants. And as we have also discussed before, the increased light intensity has a significant, straightforward effect on the entire plant physiological activity and of course on the uptake rate. Therefore, higher the light intensity is, the higher is the uptake rate of any certain nutrient elements, and because of that we should deliver fertilizers to the plants only under condition of good light intensity. Normally we should avoid applying fertilizers in when long periods of raining are expected, because this will significantly reduce the intensity of light and also the uptake rate of mineral nutrients, and we might have a gradual accumulation of the minerals into the soil and negatively affects its physical properties. Second, the temperature is also important by enhancing some specific physiological processes. An increased temperature in between the limits of optimum temperature, between the range of the optimum temperatures, will also positively affect the uptake rate of several nutrient elements. And finally, the air humidity, or more exactly the vapor pressure deficit, is an important factor on defining the uptake rate of different nutrient elements. And we have explained that before, that under the condition of an optimum vapor pressure deficit, we will have an optimum transpiration rate, and because of that we will have a normal water uptake, and with that also we'll have a normal uptake rate of nutrient elements dissolved into the water. But under the condition when the vapor pressure deficit is too low, too small, or which means that the air relative humidity is too high, the transpiration rate will be very slow, and this will also affect the water uptake and nutrient uptake. And in order to avoid that, we should be aware to maintain the optimum vapor pressure deficit all the time in greenhouse by applying continuous ventilation into the greenhouses, even in relatively cool or humid days. In addition to these three factors, other important factors affecting the uptake rate of the nutrient elements are some either synergistic or antagonist effects. Different minerals or different ions of the nutrient elements have in between, and they either can empower the uptake rate of a certain or next nutrient elements, or could hamper it uptake. And we should be very especially regarding with the concentration of the sodium ions and chloride ions in the soil solution, because they have then very antagonistic effects with other nutrient elements, and especially with calcium and magnesium, and that will result in deficiency of these elements into the plants, and we might have some serious physiological disorders like blossom end rot appeared in the plant, with significant negative effects on the expected yield. The pH of the soil solution is also very important, and that significantly affect the solubility of different nutrients. We'll talk about that later on in this lesson, and we'll explain in more detail that the desirable pH of the nutrient solution, of the soil solution, should be in between 5.5 to 6.5, and whether or not we should take proper actions to correct it and bring it in these values. The total salinity of the soil solution, the so-called either soluble salts or electrical conductivity, which we have discussed before, are also important factors affecting the uptake rate of different nutrient elements. In general, increasing the salinity of the soil solution will have a straightforward negative effect on the uptake rate of different elements. Overall, the increased salinity reduces the growth rate and reduce the expected yield from the crop, but on the contrary, it has a positive effect on the quality of the product, especially in fruity vegetables like tomato or watermelon and melons, which have better coloration, more aromas and higher sugar content in the fruit tissues. And finally, the level of humidity or the moisture in the grown medium is very important too, and I'm not going to talk longer about that last factor because we have already talked in detail when we'll discuss the water requirements and irrigation methods in the previous lesson.